Okay, I had a little editing error there, so we have part 2.5 of 3 parts, and this is scaling. What we're going to do is throw a scalar into the mix. So let's see. We'll start again with vertical scaling. So this is where we'll take a function like f of x, and on the outside of the function we will multiply it by some constant. Okay, so notice this is outside the parens, and so outside the parens means that we will change y values only. And how it works is like this. Let's take a garden variety function here. We will either stretch or compress our graph. We can stretch it vertically like so, or we can kind of flatten it like so. And with that drawing, I don't know what you got when you finish, but here's how it goes. If our scaling factor, which I have as a constant c here, let's see, if the absolute value of that factor is greater than 1, then we will get a vertical stretch. The 0 is going to stay in place, but everything else is going to be stretched up, whether it's inside or whether it's positive or negative. If the absolute value of our scaling factor is between 0 and 1, then we will get a vertical compression. Here's a graph that gives us a really good look when we stretch it or compress it. X cubed minus x. Now, today we're looking at very elementary functions. In a couple of weeks, we'll be talking about how you can look at this equation and know that this is exactly the picture you're going to get with it. We have a lot to learn here. Okay, in our first sample here, I am multiplying on the outside by a value that is greater than 1. So this is going to give the effect of stretching it vertically. Okay, let's turn it on. Ooh, there it is. Now, I want you to notice here, the zeros of this graph stay where they were. The positive values are pulled up higher, the negative values are pulled down lower, but the zeros stay exactly the same. So it's as if it were grabbed in the middle and pulled apart vertically. Okay, now let's look what happens when we multiply it by a number between 0 and 1, in this case 1/4. It's still going to be like grabbing it in the middle, but now it'll be grabbing it in the middle and pushing the ends toward each other. The zeros have not moved, but everything else has moved closer to the horizontal axis. That's what I mean by a vertical compression. Okay, so next we will do a horizontal scaling, and not too surprising that the horizontal scaling is a matter of a scalar inside the parentheses. So, and I think it's also not going to surprise you that we have an effect that's contrary to what we would probably expect with this. So, rather than multiplying on the outside, I'm going to multiply on the inside. Now, if the absolute value of c is greater than 1, rather than stretching horizontally, I'm going to have a horizontal compression. I'll be pushing it together from the left and right sides. Okay. And if the absolute value of my scaling factor is between 0 and 1, I'll get a horizontal stretch. Okay, let's look at this with the same function inside Desmos. Okay, so we have x cubed minus x, and I'm carefully enclosing x inside parentheses with my scalar here. Okay, so when we multiply inside the parentheses, you might expect it to be stretched horizontally, but on the contrary, what happens is it is compressed. So, notice the y values are not changing, but the x values are changing. This one is in fact 1/3 of what it was there. So, think about this. Here, the big black dot says it's negative 1/3, 0. If we multiplied by 3, then we would be back to normal. That's how that works. And here's another one, a positive 1/3. Well, if we multiplied this by 3, then we'd get back to what we started with. I think this is a little easier to understand than it was to understand the left and right movement. At any rate, it makes more sense to me. Now, what happens when we have a scalar between 0 and 1 inside the parentheses? Well, that's what we do to stretch it horizontally. So it doesn't stretch vertically at all, it's just pulled out to the side here. And so this, if we take half of that negative 2, then we'll be back where we began. If we take half of this positive 2, then we'll be back where we began. And if we take half of 0, well, no change. So I believe that's the end of this segment.